Thank you for joining us for Cota Access. My name is Albert Azu, and I'm a partner at Cota Capital. Cota Access is a recurring webinar series that we host several times per year, where we bring together founders, thought leaders, leading executives to explore a variety of business and technology trends that are impacting large enterprises. For those of you who do not know us, Cota Capital is an SEC-registered multi-stage investment firm. We're based in San Francisco. Our focus is on US-based enterprise technology companies. Since the beginning of the firm, we've invested in over 75 private and 25 public companies. Our focus is on companies innovating in infrastructure and workflow automation, and we also focus on several verticals, including fintech and life sciences. We're always looking for passionate founders and transformative companies. So we welcome the opportunity to meet you. Please reach out to us. And you can reach me personally at albert@cotacapital.com. I'll now let our operating partner, Simone, kick off today's Cota Access and introduce you to our panelists. Thank you.
Thank you very much, Albert. And panelists, online attendees, welcome to Cota Access, a regular series of events covering technology and entrepreneurship. What is Cota Access in one line? Industry experts discussing a single topic in depth. And of course, we think this is a good use of your time. And today we have an interesting topic to discuss. Today is not just about machine learning in general, though, but we will quickly dive into machine learning ops or MLOps and practical tips to deploy machine learning workloads effectively. In fact, the tagline for this event is overcoming deployment challenges with MLOps. So quick housekeeping. My name is Simone Brunozzi. You can guess I'm from Italy from the name. I'm an operating partner at Cota Capital. I'm your host today. This event will last for 60 minutes. We will end at 11 a.m. Pacific time, so in just slightly less than 1 hour. The event is recorded and it will be made available afterwards, so you can also rewatch it or share it with friends and colleagues. You can ask questions on Zoom. You should be able to do so in a private mode, so we will read those. And we might be able to pick one or two of your questions during the event. That's it. Now, before we actually introduce the panelists, this is something I really like to do. As usual, we get things going with a provocative question, and then we'll introduce everyone else properly. So the question is the following. What's wrong with machine learning? We were promised wonders, and we ended up with a struggle to make things work. The rage in the title, Rage Against the Machine Learning, is not only a reference to a very famous rock band, but is also a sentiment that many practitioners have experienced. What's going on? We're going to start with Ivan.
Yeah, thanks. So I guess I would say it turns out machine learning is hard, right? It is ultimately a new paradigm for developing software. And unsurprisingly, maybe we need new stuff to help us develop that new type of software. We are already, my customers anyway are buying custom hardware from Nvidia accelerators. We're hiring people with completely new skill sets who really deeply understand statistics and data science. And our organizations kind of have to embrace the highly experimental and high failure rate kind of nature of machine learning projects. So all I'll say is, as an industry, I think we need better tools.
Yeah, and I totally agree with Evan. And just to add, there's a lot of other issues too. When you're taking a lot of these machine learning systems and AI systems are coming in and taking things that have traditionally been the domain of humans making decisions, whether it's loan applications or healthcare decisions, and you're putting them in the hands of algorithms, which can be very powerful in that you can be much faster. You can bring the ability to reason about this complexity that is amazing, but you're also disintermediating, along with taking the humans out, you're losing a lot of common sense. And so being able to build these systems in such a way that, you can trust them, that you're not being reckless, that you're not being foolish, and you can have a lot of confidence that they're really working well is a challenge, and, requires both great talent and great tooling to do that.
Thanks, Evan and Adam. Part of the reason I feel that, there's continued letdown on some of the, that ML practitioners feel is oftentimes there's a significant investment in data and technology that's required in order to truly transform an enterprise with machine learning. For machine learning to become a successful reality, companies oftentimes underestimate the level of effort that's required in the data transformation, in the technology transformations that they need to undergo to dovetail with the new expertise and the new ways of working that Evan mentioned, right? And this is one of the things that we at Capital One spent a lot of time working on that I'll get to in a short while. But that's something certainly I feel as a group collectively we underestimate the challenges there.
Okay, thanks, Giri. Now, Jim.
Yeah, so I think there's a few problems here, and they span a fairly broad range of topics. The first of which I would say is, in general, machine learning engineers are usually trained to focus on more of the mathematical details that are occurring. And while that's good, I think the big problems really revolve around having a clearly articulated problem definition. To build on top of the point that was made previously is, data, right? This is a data access problem, data acquisition, deployment of the systems is different. It's incomplete or missing data can lead to bad decisions. And they end up spending 90% of their time in data pre-processing stages, and that eats away at all the time of actually doing the fun stuff.
Nice, thank you very much. Thank you to all of you. But I have to say, Jim's background is really, is really amazing. I really liked it. So now that you gave your initial answers, it is time to properly introduce yourself to the audience, who you are, your background, and a very quick intro of the company you represent. You can go ahead. We can start with Giri.
Thanks, Simone. I'm Giri Iyengar. I started my career as a researcher at IBM Watson after my PhD, building machine learning algorithms for speech and vision processing. And then I tried my hand at a couple of startups, including one with Albert over here. We both had a great amount of fun building startups together. So after that, I took on a role leading ads engineering at eBay. And then now I'm at Capital One, where I lead our experimentation, marketing optimization, and the conversational AI teams. The way I like to think of that as platforms that support delivering intelligent experiences to our customers. So now coming to Capital One itself, right? We have been thinking, knowing that in order to deliver transformative machine learning products across the business, we need to make a lot of investment in data and technology so that it allows our customers to interact with Capital One in a very natural, seamless, and accessible way. So we have been using machine learning to help our customers become much more financially empowered, helping them make predictions about upcoming bills, detect irregular expenses, better manage their spendings. We really believe that machine learning helps unlock a host new set of opportunities in the financial space. And our goal is to deliver real-time, intelligent, and automated customer experiences. It also plays a crucial role in our cybersecurity efforts and strengthens our ability to protect our customers' data.
All right. So I'm Jim Scott, head of developer relations for data science at Nvidia. I've been in the industry for over 20 years, and I've been focusing on data-related problems pretty much the whole time, working on big data well before the terminology ever showed up. And across my career, I've worked in, maybe 10 or so different industries, from regulatory to Web 2.0 to geographical systems, big data systems, and now here at NVIDIA, focusing on helping to enable the ecosystem for data science. And the idea here is that for NVIDIA, we're really trying to make people's lives better, make it so that they can focus on the problem as opposed to all of the tertiary things that really doesn't bring them joy, if you will. Everybody knows NVIDIA for gaming, but in the last 5 to 10 years, the company has put a lot of effort and rigor into the process of data science. It really took off big about 5 years ago or so for all of the deep learning types of use cases. 10 years ago was the big push into HPC. And now we're seeing the push into the rest of the realm of data science. And the big opportunity here is really to drive awareness that all of these things can be made faster, easier, simpler for the user, and ultimately drive better value at the end of the day for the business.
Awesome. I'm Evan Sparks. I'm co-founder and CEO at Determined AI. In my past life, I've been a machine learning engineer, a modeler in quant finance, in natural language processing, and computer vision. Much of this before machine learning was cool. I've also got a PhD in computer science from UC Berkeley, where I was focused on distributed systems for large-scale machine learning. I was an early contributor to the machine learning ecosystem around Apache Spark. And at Determined AI, we provide a software platform designed to help make machine learning engineers better at their jobs. So, dovetails, I think, nicely with a lot of what Jim and company are doing at Nvidia.
Hey, I'm Adam Winchell with Arthur. I've been doing AI for quite a while, like about 20 years. I started my career at DARPA, where I followed one of my college professors over there and worked on a couple AI programs back when it really was a science experiment. It didn't work all that well, but it was super fun. And then went to a series of startups. And actually, my previous startup was acquired by Capital One, and so I joined them in 2015 and got to work on a huge number of cool projects there. Ended up starting their AI group and scaling it up and working with the various lines of business there to deliver machine learning systems in production. And while there, got a very deep familiarity with all the ways that these systems can go wrong and all the problems you can have if you're not careful. And luckily, the financial services industry has a really good culture around risk management. So I learned a lot from that as well. And really felt there was a big gap in the market, both from open source and commercial solutions, about how to properly sort of deploy these systems into production in a way that you can trust, that they're performing well, they're making good decisions. Also, having the observability to be able to explain what they're doing and even kind of provide those explanations to your consumers or the people using your system and their internal and external users. And also to make sure they're not being biased, right? I mean, we've seen a lot of headlines recently about the problems that can occur when bias gets encoded into these systems. And so when I left in 2018, took a couple months off, did a little traveling, but then got to work starting Arthur with some very talented co-founders. So we were just about 2 years old. We're about 16-person company, and we've got a number of great customers, including several of the Fortune 100. Most notably, we've done a lot of work with Humana recently in providing sort of this assurance for as they roll out a bunch of analytics in the healthcare space, and some other cool companies as well that I'm excited to talk about. Truebill, the consumer fintech, we were talking about that earlier in the panelists. And so, we really just help people monitor their machine learning systems the same way you would use like an application performance monitoring solution to monitor your applications, or a SIM in cybersecurity. We provide that same level of sort of operational maturity for your analytic and AI models.
Nice. Thank you, everyone, for your introductions. By the way, Adam, quick question for you before we continue. What's the reason behind the name of your company? I never thought about it until now. Can you share it, or is it secret?
Yeah, absolutely. So a couple things. One, when you're startup, when you're early stage, number one thing you need to do is not go down rabbit holes and not get distracted. So I kind of time boxed. Like, we have an hour to pick a name. So we ended up wanting something approachable because AI is a lot of times it's intimidating for people. Arthur fit that bill. We were able to get the ArthurAI domain name. And then lastly, Arthur Samuel is actually one of the creators of, he's the guy who coined the term machine learning, the definition. He was an early IBM employee, and among other affiliations. And he was actually the first person to, as far as we could tell, to create commercial value from AI. So he, long before AlphaGo and Deep Blue, he created a checkers playing program that built a lot of, that beat a local checkers champion and helped IBM move some of their, I believe it was their 7000 series mainframes in the late 50s. And so, yeah, that's the story. Probably more of an answer than you wanted, but that's it.
No, that's great. Thanks for sharing that. Given, the panelists have introduced themselves, you, the audience, now have a better sense of how deep their expertise is, and also the fact that for machine learning in particular, and also for machine learning ops, it is very important not just to have theoretical knowledge about how things should work, but also to have practical experience. We heard, for example, from Adam himself that he has learned a lot from the practical application of machine learning techniques to real world problems. And especially in enterprise environments, when you want to deploy machine learning, there are various stages, of course. There is, development, deployment, models, stability, observability, phases or aspects of it. And many of these phases or aspects are not either fully understood, or it is not clear what's the impact that they might have in a specific project. So the question to you panelists, based on your experiences and of course your hopefully opinionated point of view, is what can you tell us about this, how the approach to deploying, observe, and everything else in the enterprise, what's the right approach? What are the challenges in these stages, and what improvements we can expect in the near future? We start with Evan.
Sure. So I'm happy to touch on all of that, but what I'd say is, while I interface with people at kind of each of the stages that you've talked about, Simone, at Determined, we really focus on that sort of model development stage, and that might seem somewhat narrow at first, but I think eventually what you realize is that one of the key things that makes machine learning systems different than kind of traditional software is that in order for them to really realize their value, you need to be continuously retraining and updating these models as new data comes in, as we learn more about the world, as the machine learns more about the world. And so I think, this concept is harder to automate than most outsiders, new to the field think. And it's our opinion that you really have to have a great training system kind of at the center of it to lay that foundation for constantly retraining and relearning. The other place that training kind of comes into deployment is that you're constantly kind of testing on held out data sets, because this is how we do monitoring, right? We need to understand how our live system is performing versus how we expected it perhaps to perform when we were in development. And so you really need kind of a good, strong system of record behind the scenes, keeping track of model versions and understanding this drift. And then finally, I think the interesting thing about how we've seen machine learning be ingested in practice is that we've started to see more and more systems where there are constraints on our deployments. So if it takes an hour to process a second of audio, services like Alexa and Siri are completely useless. And instead, you have to consider sort of the cost of inference and their latency and memory footprint and so on at training time. So having, you can't just focus on training without thinking about the end application, I guess is the point there.
Yeah, absolutely. So, the way right now, because AI as an applied practice, and especially at the scale we're talking about, is such a new field, there are all these kind of different stages and needs. And then the way that, when you look at sort of like the products that fit in at these different stages and the way they come together, it's still definitely an emerging picture, right? It's a lot clearer than it was a couple of years ago, but there's still a lot of wet cement over what are separate product categories and how they overlap, how they're discrete. And I think what we've seen a lot of initially over the last couple of years is customers, like a lot of the early success stories in AI have been around vertically integrated environments that kind of do the whole thing, like beginning to end. So companies like H2O and Data Robot and some of the cloud offerings. And that's been helpful because it's, really helped companies and organizations get up to speed on what does that stack need to look like? What are the components? But what we're starting to see is a lot of, now that companies are really sort of scaling that maturity curve and getting to a pretty mature place, they really kind of have a clearer picture of like what their needs are and what the stack is. There really is a lot of emphasis on sort of going more like best of breed and being able to like swap out different components at different layers and really assemble a stack that works really well for their particular requirements. And because every organization is different, and there's different parts of the phases that are different. Depending on that company's needs, and there's no sort of one size fits all solution for this stuff. And so, I think that you're seeing that kind of at every level where you have like dedicated companies for, whether it's feature stores or reproducibility or model versioning or observability and monitoring. You're starting to see kind of multiple companies like really focus on each of those separate layers and provide amazing solutions there and give companies some really nice choices that allow them to really kind of tailor make their stack in a way that like serves the needs of their business really well.
I want to pick up on the theme that Adam left with, right? So in order to address some of these challenges, the way we are thinking about at Capital One is to, in order to catalyze the adoption of machine learning across the business, we ended up actually possibly from the company that Adam was part of, which became part of Capital One, we created a center for machine learning. Right? And then the Center for Machine Learning essentially looks across the entire enterprise, looking for best practices, in each one of these different stages, as we, as different product teams are going around building machine learning products, so that we are sort of essentially pollinating these, best practices across all of Capital One. We're focused on building a machine learning environment, and given that we're coming from a financial industry, this environment, essentially we are focusing a lot more on making sure it's responsible, it's well managed, it ensures the highest levels of accountability, for our customers and our regulators. Right? So to that end, we have started looking into building some proprietary tools, mixing in with a whole bunch of open source tools in order to augment our governance, security, and management capabilities. So what we believe is that as companies start maturing their journey in machine learning, machine learning platforms and tooling, especially the ones that support performance management and MLOps, are going to play a huge role in order to facilitate all these stages, right? Data collection, model training, experimentation, repeatability, being able to prove the quality of your data, the provenance of your data, and along with that, dovetails nicely with the maturation of the DevOps and SRE practices, especially around when it comes to operating machine learning models at scale.
And
okay.
I think that this may not sound like a hot button topic, but actually I think it is. And I think really it's time that we rage about how crazy it is that there's a lot of places that are still doing development in Python and then rewriting it into other languages like Java and Scala. And the number of opportunities for errors to be introduced into the process is significant. In addition to that, the amount of time that gets added into the process for getting ML deployed is huge. There are numerous success stories of Python getting deployed in a scalable way with better performance than all of those alternatives. And I've seen this success with this approach at numerous companies, finance, retail, healthcare. I mean, really pretty much every industry now. So, but if I pause on that for a second, because I think that's a lot for people to consume, because if they're like me, their heads might have just exploded. I think there are some really interesting model frameworks like Onyx, the Open Neural Network Exchange, that can help alleviate a lot of problems as it relates to the deployment side and interoperability. I think that we need more standardization around logging and processes to support observability and reproducibility. When you think about being able to lock down a model and a data set at a point in time, it's fairly critical to be able to have reproducibility. We see a lot of tools like MLflow, YLogs, weights and biases, Comet, Neptune. I mean, there's just so many tools out there that fall into the space. I don't think any one of them has really risen to the top. I say there's certainly room for standardization and consolidation there. And then, if I move on even to the next step, I'd say, don't even get me started on stability.
Yes. And thanks for this. In fact, I think the right segue to this would be to do a very quick dive into observability and monitoring. You shared some, and maybe you want to add some more, Jim, but let's hear from Giri. What's his view on it?
So is stability or observability a biggest challenge or a biggest opportunity, right? So the way I would look at it is that it is, it's not a matter of or, it's truly a matter of and. It's both our biggest challenge and our biggest opportunity, right? It's the biggest near-term opportunity in terms of essentially making large-scale ML-driven products a reality. So the way I like to think about it is that just like SRE or site reliability engineering has truly transformed the way we design, develop, and operate software systems, right? The recent trends in shifting left, not just in SRE, but pretty much all aspects of software shifting left and taking a much more holistic view at the application level, at the systems level, at the enterprise level. That's where it's both a huge opportunity for us, and frankly, given everything that we talked about at the beginning of the webinar, it's a challenge for ML practitioners and software engineers alike to be able to think in this holistic mindset and shifting left a lot of these practices.
Nice. And Jim, I don't know if you want to add anything, but you probably covered your point of view already in the your previous answer. But unless you want to add anything, then we can jump to Evan and see what he thinks. Whatever you prefer.
I've got a couple more points here.
Yeah,
so
go ahead.
Yeah, I focused fairly heavily in the last question on this, so it provides a hint at how important the topic really is. But the big thing in my mind is when we look at it, data sets, they're going to change over time. And when you look at a model developed 6 months ago against the data at that timeline, it may perform differently than the current data coming in. And so having the infrastructure to do continuous A/B testing on the current model with new models allows an organization to really be able to react to those external factors that are outside of their control. And then that opens up the door into the topic of model drift, which is a real thing. And if you can't observe the performance of the models over time, it's quite likely there are going to be significant rate of decay in the overall models.
Yep. Evan?
I mean, I feel like Jim kind of took the words out of my mouth with this one. I think, the way I think about it is how is machine learning kind of production different from traditional software? And there was a really, I think fundamentally it's because the definition of what is correct is different, right? We're dealing with statistical systems, and so there's probability involved and so on. It's not like I write the spec, I adhere to the spec, and the lights are green. There was a really interesting conversation that was kicked off fairly recently in the MLOps community on Slack by Josh Wills, who's a great Twitter follow and somebody who I find super thoughtful in the space, as well as being entertaining. But the consensus of that discussion within this community was that just as with sort of traditional software, you should have a sense of when your system is hard down. That is, DNS isn't working, I can't even reach the host, I'm like timing out or whatever. Okay, fine, that's like table stakes. We all know that. But for machine learning systems in particular, you want to have a clean definition of what degraded performance means. And you have to have a threshold of degraded performance that you are willing to tolerate as a business owner. To Jim's point, data drift is inevitable. It's going to happen. Our systems are going to get slightly worse. But knowing live, to Jim's point, how much worse we are than what's acceptable, and knowing when to pull the plug and maybe go back to rule-based approach or something like that, and then further tools to help you investigate why these things are happening are essential, I think, to really improving the stability and observability story.
Adam, anything you want to add?
Yeah, absolutely. This is a subject very near and dear to our heart. But I think the case for the need for it's been well made. And the only thing I'll add is just, I think the real challenge in many cases is, when you read about, when you study this stuff in school, like AI, machine learning, like, everything's always framed in terms of like accuracy rates and confusion matrix, false positives and true positives and area under curve and all these great metrics that you have. But what they don't tell you in school is like all those metrics require a ground truth feedback loop, which like 95% of the time in the real world, you don't have that. You don't know, like if you're giving someone an auto loan, you don't know for 3 or 4 years whether that was a good decision or not, whether they defaulted or not. Or if you're like making a diagnosis, like that kind of ground truth feedback loop, just let's put it this way: when you actually do have a use case that you get that, it's like a joyous moment because it's so rare, right? And so that's what makes this performance stuff so hard to reason about, is because you don't have that, and so you have to look at things like data drift and stability of your predictions and things like that. And it becomes really critical to bring the same level of like, visibility and just clarity around that stuff that you have around these more concrete, is this working or not metrics. And so that's something that I think that the industry has grappled with. And, but I do think the challenge, there is some good news. So like a couple of years ago, or even up till recently, when teams were deploying these systems in high leverage environments where they needed that level of assurance, what was happening is they were reinventing the wheel over and over again, right? And so they were, they were, and the thing about it is like, usually you kind of like when you have to like, when you're a data science team, you're trying to deploy something and you need to do some like minimal level of risk management. You're just going to do like kind of the basics, right? Like as little as you want, because data scientists, what they get excited about are like building the next model and solving the next problem. And so it becomes like this tax that you need to do, but it's not like the fun part of the job. Which now the good news is there's some good solutions, including Arthur, where you can just take something out of the box and plug it in and kind of get this for free. And it allows people to kind of focus on the more strategic aspects of the job, which is really kind of creating better models that solve problems better.
Yeah, absolutely. In fact, it just reminded me of one of the mottos of Amazon Web Services in the early days. I was there in the early days, and it was about removing the undifferentiated heavy lifting, or actually solving the undifferentiated heavy lifting that customers had to go through. The usual things, reinventing the wheel every single day, every single time. And I think this is also happening in the machine learning world, as you were just describing. And what you just said, for this last question, points us to then how do we obtain stability? And in fact, there's also a question from the audience by Konrad Redznicak. Sorry if I butchered your name. I assume it's a maybe Polish last name. That's probably the origin. The question is about what specific tools and practices we can use to measure degraded performance and data drift. But instead of answering that question, I think I want you to answer the question of then how do we obtain stability? What's the best, simple, short answer to do that? Giri, do you want to get a crack at this?
Thank you, Simone. So if you indulge me for a moment, right? So I would like to define resilience as different from being stability, as resilience as being the ability to recover from the operating conditions. What are the operating conditions? Like if the operating conditions are dramatically changing, resilience is being able to recover from that very quickly. And stability, on the other hand, is being able to make reasonable predictions that we as builders of systems can predict about what's going to happen to these systems as we deploy them and put them into production. So there are two different aspects, and what's happening nowadays, especially, is that there is a lot more emphasis that's being placed on understanding ML systems, particularly from the point of view of stability. Right, and this dovetails very nicely with all the things that we're hearing about in the news. In addition to our regulators becoming a lot more focused on explainability. Explain how your model works. Explain what your model is going to do. Right, those are some of the questions that we at Capital One are constantly faced with. Before we put out any model into production, we go through a model review process where we discuss a lot of the stability aspects of this model. How is this model going to work, and what's going to happen to it? What are the conditions in which it's going to perform, and how are we going to measure it, and so forth. So we put a lot of thought into that, right? And in order to make a lot more progress on that, not only are we essentially putting thought and adding code to measure performance when the model is in production, we're also collaborating with a lot of academics and industry partners to specifically focus research at the intersection of explainability, stability, fairness, ethics, all of which are essentially very important for us at Capital One and overall in the banking industry. We are particularly focused on this because we think responsible AI in banking and financial services is super crucial and super important. The good news is that there are lots of statistical tools that are emerging now that can help us understand the stability aspects of the models very well. With that, I'll pass to Jim to elaborate more on some of these tools.
Yes, thanks.
Yeah, and I see how this goes. You hear me say, don't get me started on stability, and then you say, let's get Jim started on stability. That's okay. We'll go deeper on this. So one of the major things here for me is around building a model that's not overfit to a training set. And I hear people talk about this all the time. And when you think about it, if you're overfit to a training set, you end up yielding poor performance when you start looking across a much broader data set. And where I think this is interesting is you start to see a level of consideration for model stability where, inherently you have these models for different types of use cases that have stability issues where you wouldn't necessarily think about it in another type. So if I provided an example of building a melanoma detection model, so long as it's well trained and not overfit, it's likely to be stable over time, which is quite different from a recommendation engine where an individual's preferences change significantly over time, thus producing stability problems in the form of model drift. So when we look at it in this context, we have to understand when and how to retrain these models to produce stability, and it is going to vary by industry type of use case.
Evan?
So I'm gonna say something a little bit controversial, and maybe not that controversial when you think twice about it. But I would say that instead of hoping that you're going to deploy a model that is going to be stable over time, we should just give up on this concept of stability, at least in the narrow, and embrace the fact that, like Jim says and Adam, that our data changes over time. We get this drift. That is a real factor in what it means to deploy production machine learning systems. So instead, what I'd say we should be focusing on is shipping the minimum viable model, as I like to call it, the MVM, the thing that improves on the previous business process by epsilon, but one that has behind it some notion of a continuous feedback loop to improve it in place. So this is hard work, right? Like it took me 6 months to develop this model. You tell me I've got to think about the frequency with which I want to keep it updated and how to collect the real world labeled examples that are downstream and so on. But I would argue that if your business problem is critical enough to warrant an investment in machine learning, it's probably critical enough to warrant investment in this notion of an improvement pipeline. So in response to the question from the audience member, I think Adam's point about sort of lagged responses in many of these real world machine learning systems is kind of at the core of what makes this hard. And so I think, in my opinion, the single most valuable tool that I've seen to combat this is something that is anything that's going to sort of tighten that feedback loop. And so things like, let's come up with a proxy variable for the effect that we're trying to measure. Okay, if I don't find out that a loan is going to default for 3 or 4 years, maybe there are some indicators that I can collect much sooner, say late payments or something similar that happen far earlier in the process, and use those as the target of my monitoring and continuous improvement. It's an idea. I'd be interested to hear if the other panelists have examples of tools like that.
Yeah, absolutely. I think just to build, I totally agree with all that. And, being able to track sort of like kind of key business indicators or key like kind of performance metrics that aren't necessarily like the direct, like did this model make a good decision or not, but kind of give you an indication that overall the system's performing pretty well, and sort of like being able to look at those over the same time period as your other model metrics is, it's critical to really getting it right. I think there are some number of good points made. The other thing I would add to what's already been made is, in addition to kind of like looking at this as like a technical system, as a system, an engineering system, you really also have to think about like the stability. Stability includes like the humans who are maintaining this. And so, one of the things that we really work hard to do is like, if you monitor, if you're a data science team of like 100 people and you've got a couple hundred models running, let's say something like, when a global pandemic happens, when COVID happens, some of our companies, a lot of their models were heavily affected by just this massive shift in consumer spending habits and healthcare habits and things like that. And so, a big part of stability in that context meant like knowing which models were the most impacted, and especially the high leverage models were most impacted, so that they could marshal their human data scientists to really address those, and whether it was retraining or whether it was putting in some rules, just to kind of like make sure that they're not getting caught flat-footed by this huge change, allowed them to be a much more stable kind of at an organizational level, not just at like, for each individual system.
Thanks. Even I want to just launch a quick provocation, but I don't need you to answer this right now. I would say, in theory, if you did a very good job at the beginning, any black swan event or unpredictable event shouldn't be able to drastically reduce the performance of your models. But I know this could be a very controversial discussion, or at least it would take us a lot of time. So I just want to throw it there and then hide my hand, and we can talk about it maybe offline at another time if you're willing to. But I wanted to ask you about hardware acceleration and the role it has on MLOps. But I think that given where the conversation is going, I would actually skip that part and jump directly to the hot topic, which is MLOps. I think it will be useful, given your experience, one, to maybe try to give a high-level practical definition of what it is exactly. What's the difference, for example, from DevOps, which all of us, I assume, at least the technical people in the audience, know very well, and does it help solve the problems that we have described thus far? Giri, do you want to start?
Sure. Thank you, Simone. So I would like to view MLOps as bringing some of the best practices of modern software development to encompass machine learning and data science as well, right? So in that sense, it's a natural extension of DevOps, but brought to an ML-centric software development. When we talk about machine learning ops and model performance management, in my opinion, there are at least three different components that we need to worry about, right? The data, the model, and the code. Traditionally, we worry about the code, but in the case of ML ops, we need to worry about the data and the model as well, right? And ML ops, some of the advantages of shifting to this ML ops mindset is that when you think about integrated teams of data scientists and engineers working together in an ML ops framework, it helps dramatically reduce the friction that is involved in taking models into production, but allowing data scientists and engineers to work together as opposed to writing it in Python and then retranslating it into Java, as Jim was talking about earlier, right? So removing these kind of bottlenecks. It enables teams to focus on repeatable workflows and data pipelines that allow the process of iteration and model operation to work in tandem. So you're experimenting and you're putting models into production, and it's happening in sort of this fairly nice iterative way. It also helps a lot, especially in the context of the industry that I come from. It helps a lot with the governance and the regulatory compliance aspects. These kinds of systems enable practitioners to reproduce models, models at a point in time, models, as they're running, so that we can reproduce them back to their original specification, which is a topic that is getting increasing attention and increasing scrutiny as more and more machine learning products are flourishing in the wild.
Yeah, and if I can add on, and in an attempt to not be redundant with what Giri just said, when you stand back and look at MLOps, conceptually, it's the same thing as DevOps. There's a twist to it though, and that comes in the form of the process that machine learning folks have to follow. And if you really want to think about this, everything happening on the ML side, it's just part of a bigger system, right? It is one component of the whole. It's not something running in isolation. And so if you really want a thorough understanding, I would generally tell pretty much everybody, go check out the paper written by Google titled Hidden Technical Debt in Machine Learning Systems. Importantly, there are dependencies on data sources, sometimes real-time event streams, other times logs getting moved, data warehouses. There's other considerations for the models, like whether they're going to run in batch, real-time, whether they're part of an ensemble, if there's downstream consumers of these models. And all these things have to work harmoniously together. And one of the big highlights of the paper that Google put out there is there's a big highlight in there of undeclared downstream dependencies. So someone consuming outputs from these models and you don't realize it's happening, it will have an impact on your systems and your processes. And if you don't have a good MLOps process, you'll end up making this more like, my, what a tangled web we weave, right? And that will surely result in some type of trouble.
I think the thing that I'd add to that is really, sounding like a broken record here, is that the way, when I think about what DevOps is about, in a lot of cases, it's how do I make sure that things running in production continue to run in production, right? And that means dealing with failure. And I think that the big difference between MLOps and DevOps is that the way things fail is just different. And some of this is, to some of the earlier points, that most DevOps engineers haven't been trained in machine learning and deep learning. They don't know what vanishing gradients are. They can't necessarily spot statistical anomalies as easily as they can spot other things that are wrong with their traditional systems. So I think there is a component of education, re-education that needs to happen. But there's also a component of responsibility among tool creators to make, as part of the MLOps ecosystem, to make the lives of those DevOps engineers easier and help them more rapidly understand the failure modes that they're being subjected to.
Yeah, I agree with all that, and I think the only other thing I would add is like MLOps is the term's been it's definitely a trendy term right now, and it's coming to a lot of use in it. And like so many things around sort of the AI ecosystem, it's very it's used very differently across different by different people. But I definitely think that has been sort of alluded to by other people here. Like it refers to anything that anytime you're trying to get a model off of a data scientist notebook and actually doing stuff in the real world, that's what it refers to. So it includes like all the CI/CD type activities with companies like, there's a bunch of companies doing that, and as well as kind of monitoring and really providing the observability. And I think it is it's exciting to see it mature, because I can tell you, like 3 or 4 years ago, when you were building these models, those tools didn't exist, and it was very manual and very painful to do it. So it's really I think as these tools get more mature, it's really going to be an accelerant towards AI adoption.
Got it. And I think this leads to, we spoke about some of the specific challenges, but what about, language modeling, or what about computer vision, for example? How are these in the context of what we just discussed? Evan, if you want to start.
Yeah. So how are these two, prominent use cases of AI today, computer vision and language modeling, different from one another from an operational perspective? So first thing I'd point out is that the models in language modeling tend to be much bigger and kind of data hungrier and compute hungrier than the computer vision models, which can be surprising to people. You think pixels and complexity of images, and you think they're like way harder to understand. Turns out human language is pretty difficult. And so you start to worry about things like, even at the training layer, model parallelism versus data parallelism. A lot of products in the space are built with just the latter kind of assumption in mind. And so you may need to be re-engineering your systems to account for a new use case, which is surprising to folks. The other thing I'd say is that from an ops and kind of DevOps and even development perspective, is that in language modeling, the concept of like a pipeline that has multiple stages with multiple models composed together is much more common than it is in computer vision. You see some of this in computer vision, but look no further than some of the work that's being done in Hugging Face and some of the interesting kind of NLP projects out there. You see pipelines everywhere, which I think is pipelines are near and dear to my heart, and I think is super interesting.
Yeah, absolutely. I think there's also this is definitely one of the biggest drivers in sort of a lot of design decisions that get made. And I think for computer vision in particular, because it is so it can be so the data volumes are huge, right? Like if you're doing something that's like interpreting real-time video and combining it with like multiple cameras and LiDAR data, like some of the autonomous use cases. It really kind of fundamentally changes sort of the way, like, you then have to deploy the intelligence on the edge, maybe because you can't possibly like have thousands of these entities streaming data back to a central platform. And so then the way you sort of design your system is just fundamentally different for these types of use cases. Really being able to like push stuff out to the edge and decentralize it can be a huge challenge. And things like language models or structured tabular data type problems that you tend not to have quite the extreme data volumes, and so you can take a more centralized approach. So that's just one of many different design considerations that are brought on by these radically different data types.
In addition to some of these points, I would like to draw our attention to another interesting challenge that comes up, especially when you're dealing with GDPR and CCPA and the kinds of things, right? So I'd like to offer that modern machine learning, modern language modeling, computer vision systems, all of these rely on huge amounts of data. And then when you factor in this need of data with the facts about when can you use some of this, what kind of data can be used when, right? And the constraints around who's allowed to use what data, which model is allowed to see what data. For an MLOps system, that can quickly become extremely complicated. So what you can and cannot do, and how do you ascertain that, becomes a huge challenge. And that's where I think MLOps tooling can dramatically help, can make it very, very, can take something that can be easily a gnarly problem of, am I allowed to do this or not, and try to turn that into a much more easy, seamless operation for practitioners to deal with as they're going about training and retraining these models and putting them out into production.
Yeah, so I'll just add a couple more little small thoughts onto this, and that is fundamentally, these are going to be very workflow and data pre-processing pipeline dependent. Right? Because when you look at a computer vision pipeline, what you're going to see, typically speaking, if you're in the training side of the pipeline, you're going to see a ton of image manipulation happening, right? Resizing, cutting out of the images, doing colorization, maybe looking for color spectrum. All of those types of activities, they look and feel very different than on the language modeling side, which is extremely heavy as it relates to structured and unstructured data sets, where you may need to do a lot of entity resolution, a lot of additional feature engineering around what is the context of the language, right? And so when we see this, it basically lends itself to going down the direction of, do I have a tabular data problem or an image data problem? And we tend to see these kind of run off in their own directions, just under natural, here's how people do their workflows.
Got it. Thanks, Jim. We are almost at the end of our online event. We have time for maybe one more topic to discuss, which is how do we make scheduling and training for models faster and more efficient? We can refer to these even as model adaptation. Giri, you can start.
Thank you, Simone. So I believe this is where the MLOps tooling can play a very important role. It'll enable product teams to bring models to life faster, right? So especially nowadays, there's a lot of pre-trained models available, widely available, and that can be used as a good starting point. And then the academic community is constantly putting out new papers on different ways of fine-tuning, model adaptation, and combined with easier access that we have to GPU hardware, you can easily provision Nvidia hardware on the cloud these days in a matter of seconds. All of that is now making things that were previously not possible, even about a year and a half ago, except for really large companies. Now they're accessible even to the smallest of startups very quickly. And then when you combine that with open source tools like Apache Airflow and the popular machine learning modeling frameworks that are out there that are increasingly supporting model interoperability in terms of sort of easy support for Onyx that Jim mentioned earlier, I believe that we are in the cusp of truly unlocking MLOps by making scheduling, retraining, and iterating with models faster, bringing us to the world where observable, stable, and reliable models will become very soon standard practice in how we actually develop ML-based software. So I believe that the ingredients are starting to fall in place. They're not yet fully there, but you can now just start to see the light, saying, oh yeah, we can see all these tools now starting to form in place, that we can see a path to putting them all together and realizing this vision.
Yeah, the light at the end of the tunnel. Jim.
Yeah, I think I could probably go on about this topic for quite a while, but I'm going to look slightly inward at this question, and that is, I think everybody out there should be looking at accessing, leveraging, utilizing, making available hardware acceleration for machine learning. And when I think about it, I try to put it in this context, which is at different scale factors, people think differently about what it means to save time. If an individual waits 100 milliseconds instead of 1 second, they tend not to think about it very much. If they end up waiting 1 second instead of 10 to 20, they start thinking about how much they really enjoy not having to wait 10 times as long. When you get running into hundreds to thousands or tens of thousands of tasks at scale, not only does it add up to a very significant amount of time, but you end up creating this real difference between being a market leader and in last place. And my final thought on this would be pretty much folks should heavily consider leveraging accelerated tooling, especially in the realm of automated hyperparameter optimization, because this is where a lot of time gets spent. And the more time you can save the machine learning data scientist folks, the better off you're going to be.
Evan?
I have a pretty straightforward opinion here, which is you should use determined AI. We have a open source platform designed to solve exactly these problems. To Jim's point, we have the world's best algorithms for hyperparameter optimization baked into the product to the point where you don't even have to think about how to use it. The system will leverage these algorithms for you automatically. There are also other parts of the training and development process where we see data scientists waiting a week for a model to converge, and on like super fancy accelerated hardware from Nvidia, we have tools that will allow them with one flip of a config flag, use more hardware, throw more hardware at the same problem, and take that week-long training time and get it done in a few hours. It costs money, but data scientist time is expensive, as is being late to market because you can't innovate fast enough. And so giving people the option to use that tooling and make it super low barrier to entry, I think that's sort of the dream of all that we're doing in sort of the MLOps world.
Nice. Adam?
Yeah, so when we think about kind of increasing the speed of that adaptation, there's a couple of things we think about. One is, as Evan mentioned, like especially with like a lot of these more modern deep learning models, and the training is expensive, and so when you want to train them, you want to make it quick. You can spin up a bunch of with cloud providers and infrastructure. You can spin up a bunch of GPUs pretty well. But the thing is, right now, a lot of people are doing it. Most people don't have that automated kind of refit and retraining and adaptation. But the people who do, it's usually a time-based interval, and that ends up not being an efficient use of your limited, constrained computational hardware. And so, we really help people like figure out like, all right, hey, the world's changed. You need to retrain your model right away. Or, hey, I know it's been a month since you last trained your model, but it doesn't matter because things are still pretty similar. So use those computational resources everywhere. So we help people optimize their adaptation that way. And, to kind of play this forward a little bit more forward-looking, like, with the technologies like reinforcement learning and continuous and online learning, where this adaptation cycle is sort of even more kind of at the core of the way they work. You want to make sure that as the system becomes more autonomous and starts doing more of that adaptation on its own, like having that observability and those guardrails in place becomes even more critical, right? Because if your system kind of adapts in a way that you don't want it to adapt, or a way that's problematic for your business, you need to know that right away. So like the more sort of like autonomy that you give these systems, the more important it is to have those intelligent guardrails that make it sane.
Nice. And unfortunately, I would love to continue for like another 6 hours, but we are at the end of the hour. So I want to thank you all for participating, the panelists, but also the audience. And now, as I mentioned, we will put this event online in a couple of days, so stay tuned. And we are now going to show you a disclaimer slide for the next 60 seconds. So you're supposed to read this. Thank you very much for attending. Thank you, panelists, and enjoy the rest of your day, everyone. Thank you.
Yeah, thank you, Simone. Thank you.
Thank you. Bye.
Thank you.